Hello, this is Roger Liu with the Virtual Technology Lab at the University of Idaho, and this is the 10th tutorial for the Virtual Cities for Unity3d set of tutorials. And in the last tutorial, we figured out how to give our humans jobs, but I discovered a couple bugs after we left off, so I thought we would start there. The first one is that we actually have child labor. So here we have child 32782, and they're 15.59 years of age. Maybe that's, a decent working age, but they're actually working at a factory. And that's maybe not so ideal. So let's go ahead and fix this problem. We'll head to our human script, and basically, if you recall from last time, what's going on is we have our start function, and we're using this on day change handler event manager basically to run the seek job method every time the day changes. So when the day changes, the time controller detects it, and then because we do the plus equals, it knows to run seek job on this particular instance of the human. So basically, we only want to do this if our human is an adult. So we can do if human type equals human type dot adult, do this. And then the second problem I ran into is that some of the workers had accumulated like 4 times what their salary was over 1 year, which is pretty much impossible unless their walls are white and they're cooking something else on the side. So we need to fix that. And basically, in our workplace script, in our job class, we have this hire function. This hire function isn't checking whether they're employed, and the job seeking is also not checking whether they're employed. So let's go ahead and kind of fix that while we're at it. So if you recall, in here we're generating this random variable, and then that determines, like based on their attainment drive, whether they actually search for a job or not. And right now, if they have an attainment drive of 1, they're pretty much searching for a job every day. And that's probably a little unrealistic. Like maybe they only search like for jobs once a week or every 2 weeks. I mean, there's a lot of workplaces to go through. That would be a somewhat involved process. But basically, we need to know here whether they're employed, and we can look that up by looking at whether they have a workplace identified. And to just make the code nice, I think I want to create a public property that I'll call employed. And this will have a get method that will basically return workplace does not equal null. Then we can also use our expose property decorator to actually see it. And since we don't actually need these set methods, I'm just going to get rid of them. No, there's no point having code that you're not using. Alright, so then, when we're doing our job seeking, we want to make that conditional on whether we're employed. And I want to make it so if you're employed, you'll still job seek, but maybe you'll only do it every 180 days, approximately, instead of every 14 days. So if I change this to 14, then the probability would be that they would like seek a job roughly every 14 days. And then basically, if they're employed, then I would want to do 0 and 180, so they would seek roughly every 180 days. And there's a trick in C#, well, maybe not a trick, but an operator called a ternary that will let me do this right here in the code. So if I type employed and then question mark's the ternary operator. Whatever comes after this will get evaluated if employed is true. So if they're employed, I want 180F, and then if they're not employed, then I want this to be 14F. So basically, if I do a condition and then a question mark, if the condition's true, then what comes after the question mark gets evaluated, and then if the condition is not true, whatever comes after the colon gets evaluated. So there's a nifty little trick that can be used to make our lives a little bit nicer. So I was kind of playing around with it, and instead of having the GUI D, if you remember this, I think I was just looking for a way to show you what a GUI D was, but I think it's going to be easier if we just have a reference to job. It just makes more sense. So we can just have a public job reference to job. And then inside of the workplace, instead of doing unique ID, we can do job.this. So we've halfway solved our employees being able to have more than one job problem. But the next thing we need to do is actually have a way of unhiring employees. I'm using the term unhire because they could quit, or potentially we could fire them. So it'd be nice to just have one method that does both. So we'll call it public void unhire. And then in this case, we'll do human.employee. And then we basically need to do the exact opposite of what we're doing here. The first thing we should do is actually probably check to make sure that they're actually in this list of employees. So we can do if not, so employees dot contains employee. So if employees does not contain the employee that we just passed in, then we do whatever is right here. And so what I actually want to do is throw new system dot exception job does not contain employee cannot unhire. And hopefully this should never get raised if we do everything else correct. And then we'll, instead of add, we need to remove the employee. Then we need to set the workplace and job properties of the employee to null. So we can do workplace equals null, or employee.workplace equals null, and employee.job equals null. Then, when we're doing the hire, after we check to see that they meet the qualifications and the positions available, we can check to see whether they're employed. So if employee or applicant dot employed, then we'll throw new system dot exception, and we'll say oh, it looks like I discovered some sort of hotkey there. Throw new system.exception cannot hire applicant. They are already employed. And you know, it might be possible for someone to have like 2 part-time jobs. At this point, we're not going to worry about it. I just want to put this in here so I I'm validating the state of my applicant. Because what I want to do is have the employee quit in their seek job script if they find a better job. So now we can move back over to our job script. So in our seek job, if they actually make it down to here, they might actually be employed. So we could do if, well, we have our ternary trick. So when we're looking through the jobs, we need to compare the best salary to our current salary, because it only makes sense to change positions if you're, well, maybe you really dislike your job and then you're willing to take a pay cut, but our humans don't really have any emotions yet, so they're probably only going to take the job that pays the most. So we can do employed. And so if they're employed, we want to use our current salary, and that would be job.calculate salary job skill. Otherwise, we want to use 0. And we're setting this to null, so this will only get, best prospect will only get set if we find a job that has a better salary than our current job. So in that case, then we would go down to here. So basically, if we found a prospect, we're inside of this loop, or sorry, we're inside of this if statement. And if we're employed, then we need to quit our current job. Can even make a little note here. Quit current job. Okay, so what I'm going to do is save both of these. I'll run it for a year, then we'll kind of double check the data produced by human data. Okay, so let's see. So since I have job here, then here I can't have job. So I'm going to rename this to underscore job. Okay, so that went away now. Now I'll go ahead and play and probably speed this up for you. And then we can head to our human data dump. I've actually already gone ahead and modified this to spit out some additional parameters. So we are now spitting out name, residence type, residence monthly costs, human type, age, intelligence, education, attainment, drive, experience, job skill, workplace. I believe all those, well actually I think the work from here on is new, and then residence monthly cost is new. Just to show you the changes, basically we've modified the string format, and then in here we're using our ternary trick that I just showed you. So if we go back to Unity, we can generate a report. Then we will open it up and take a look at it. I'll go ahead and generate a pivot table. So we can filter by, well, let's do residence type on rows, and then we can do filter by human type, and we should be able to do salary here. Let's see, did I? Okay, yeah. Actually, let's do human type in columns. So we have a 0 for the salaries of all the children, so that's good. And then we'll want to look at wealth. And I'm going to move human type back over to the filter and then exclude the children and look at their averages. Okay, so yeah, they're 8,976 over for suburb dwellers. Just double check the max. So someone was able to save 63,000. And here we can actually sort by wealth. That might be informative. So we have an adult that makes $68,980 a year, and he saved $63,000 of that. I guess could be possible. So that solves that problem. So I started implementing other workplaces and assigning jobs or making up jobs, and it was starting to get a little bit tedious, and so I decided maybe an automated approach might be better. So the census, United States Census Bureau, has data. It's not the most recent data, unfortunately, for occupation and education earnings. So if you look at the entire United States, this is for 1999. This basically lists out different occupations by categories. So here we have management occupations. We move down, we see business and financial operations. We keep going, we have computer and mathematical occupations, architecture and engineering, so on and so forth. So what I did is I copied this data, just by selecting it and copy and paste. And I put that data into this spreadsheet. So I took out a lot of the header information. So what we're left with is total counts. This is earnings across all the earners, and then this is the percentage of all earners with a college degree. And then here we have percentage of full-time workers identified as, or categorized as working 35 or more hours a week. And then we have annual earnings for full-time workers. And then this is the percentage that have a college degree of the full-time workers. And then we need to get this into Excel. And for that, I wrote this Python script. I'm not going to walk you through it, but basically what it does is it turns it into a CSV file. It takes the categories and it makes that the first column, so each occupation will have the category listed. It also it handles the line wrapping, and then some of these descriptions have commas in here, and so we need to put quotes around them so they show up nicely in Excel. So from there, if we run this Python script, we generate an Excel spreadsheet. This is reporting the names. It's also replacing the commas. You'll see why in a bit. And if we open up the output of the Python script in Excel, this is what we have. So now you can see the occupation category is its own column, and we have the other data. I also removed the commas and dollar signs from the annual earnings. And so from there I produced this Excel spreadsheet, which, if I go up to the top, has a header on it. So now we have occupation type, occupation count, medium income, percent grad. I deleted out some of the columns I don't really need. Percent population. And so these come directly from the categories. For this one, I'm taking the total count, which is 135 million workers, and then dividing the count by the total count, which is 135 million, and then timesing by 100, just because the other percentages are in are between 0 and 100. And then I also double check that this column actually adds up to F. And for most of these, they're pretty small. I'll go ahead and sort these by percent of population. And then let's do that descending. So we can see that basically 1 out of 3 full-time workers in the U.S. are secretaries or administrative assistants. 2.5 out of 100. Well, yeah, you get the idea. 2.5% are driver, sales workers, and truck drivers. About 2.5% are elementary school teachers, so on and so forth. And actually, over the first 200 jobs or so, you actually end up accounting for about 90% of the jobs. So if you create a cumulative percentage, it's yeah, by the 200th out of 505 jobs, you've basically accounted for 90% of the population. If we look at the median income distribution, you can use the histogram function here. We want a chart output. We want column D. This has labels. Let's put it on a new ply. I'm not going to save this. Okay. We can see, probably as you would expect, that there's a long tail. There's it's not very normally distributed. So what I did is I took the log of median income. So I'm just taking the log of column D. And if we look at this, now we want G. We can see that it's pretty well normalized. And if you recall from when we constructed job skill, we actually went to a fair amount of trouble to make sure that job skill was a fairly normal distribution. So what I actually want to do is to take these log median values and normalize them. So over here I'm looking at the min and calculating the min and max of the log median income. So we can see the min is 4.13 and the max is 5.09. And so in this column, I'm basically normalizing it between 101% of the max and the minimum. And then, as you would expect, the minimum is 0 in this required job skills column, and the max is 0.95. So that, because if I normalize it between 0, if I normalize this column between the minimum and the maximum, then there'd be a job that had a job skill of 1, and that would be pretty much impossible. Okay, so basically these still have formulas in it. So what I did is I copied these, or I selected all the data, copied it, and then on this sheet I pasted these as values. So I did paste special values, and then that basically takes out the formulas. So now these are just numbers. And then I did a save as, and then I saved it as a CSV file, a comma separated values file, and I called it US Census Data Occupation Income. So from here, we can bring this into Unity, and we'll load it to pull jobs that represent the actual distribution from United States Census data. Basically, the way this will work is we can define workplaces, or we can locate workplaces in our city. We can draw them to whatever size we want, and then we can assign them a occupation type. So there'll be management occupations or business and financial operations occupations. Some of these don't quite make sense in that way, but I think it's probably close enough that it'll work out. And we even have like food services in here, and the incomes are pretty much as you would expect. All right, so then if we go into Unity, I'm going to go ahead and stop this. And inside of my virtual cities folder, I'm going to create a resources folder. Unity has some special classes that look for resources or resource folders and make it easy to load data from resources. And then I'm going to take the CSV that I generated and put it into here. And now, if you recall, if we click on the factory, which is a workplace, right now we have this jobs list that we specify. So basically, I want to change this so there's a field where I can specify a string that points to this resource file, and then I want a drop down that allows me to specify the occupation type of the workplace. So something like this, except with the job types. And lastly, I want something that lets me specify how many occupations I want at this workplace. And I'll have a method that will generate a random list of those jobs and basically populate it here. So instead of having to manually define these, I just change two things and bloop bloop, I get this all defined for me. So what we need to do is open up our workplace script to start, and we'll need to define an enum of the workplace type, and I used my Python script spit this out. So my Python script spit out this list right here. So I can take this list, and then inside of here I can do public enum workplace type. Occupations is actually in here twice, so we need to just remove that. It won't matter for, well, or you'll hopefully see how we'll handle that. So we need to load in the data. We need to load in basically each row of data. And to do that, I want another struct to represent the data, to represent the individual occupations. So since we already have something called job, I'm going to call this occupation data. So I'm going to make a struct called occupation data. And basically here, I'm just going to represent the column names that are in our file. So basically, I want these column names. So here I can do public, occupation type, and then I'll have to come up with a different name. And here I'll do public string occupation, and then need a semicolon. And then we don't actually need all of these. We don't need count because we have % population. We're not really doing anything with % grad at this point, but I'm going to save it anyways. We don't really need the log median income. That was just kind of an intermediary. All right, so now we have a data structure to hold our data. And now we'll need a method inside of our workplace to actually read through the data. So to read through the data, I'm going to use a Unity package that I developed, and that's available on GitHub, called the Dict Reader. So if you Google GitHub Virtual Technology Laboratory Dict Reader, then inside of here, you'll see this Unity or VTL._IO.Unity package. This is what you'll need. So basically, you can click on this, and then if you click on raw, it'll download the actual .unity package. And so I'll go ahead and just do save file. And then if you double click it in your downloads folder, so if you double click it, it will basically decompress it, and you'll get this import Unity package dialog box. You can go ahead and just hit import. And basically what this does is this provides an easy way for us to open up that file and read through it. So the first thing we'll need is a string, a public string, to define the resource location. So we'll do public string job database resource location. And then to make sure I don't mess this up, I'm going to copy and paste the name. Oh, and then actually you don't want the extension. So this uses something called resource.load text asset, I believe. And then our workplace will need to have the drop-down dialog to specify the occupation type. So inside of here, I'm going to create a public occupation type. I'll just call this occupation type. And then we'll also need a field to specify the number of employees at this particular workplace. So actually now if I go back to the inspector, that should actually populate. All right, and here's our resource location, here's our occupation type, and then here's our number of employees. So here I'm going to create a void load occupation data. And I want to load the data into a dictionary. A dictionary is an object that's actually in the system.collections.generic namespace. So you have to have using system.collections.generic in order to use it. And basically, you can store key value pairs. So a key is basically an object that you use to look up another object. So you can kind of think of it almost as like a lookup table. And I actually want to define that in my class namespace as a class property. So I want to do public dictionary and then it takes the template parameters. So you specify the type of key, and then you specify the type of value of the values. So the key type is going to be occupation type, and then this is actually going to point to a list of occupation data, because each occupation type has several different occupations in that category. And I'm going to call this database. And actually, I don't want this public, so I'm just going to leave it private. There is actually an explicit private keyword, but since not having it is the same as having it, I just don't do private. But you could put private on your methods and on your attributes. Alright, so then in our load occupation data, we need to initialize this dictionary. So we can do database equals new dictionary, and then IntelliSense helps us out. And then what we need to do is we need to loop through all the different occupation types, so all of these things. And for each one of these, we need to create a key value pair in our dictionary that we just created, our database dictionary. So for each one of these, we need to create a new list of occupation data. So to get the values of occupation type, you can do system.enum.getValues, and then you can give it the occupation type. Except this actually wants an enum type, so then you have to do type of. Here, and that essentially returns an array of objects, but we really need an array of occupation type. So then we can do occupation type, open close square bracket, and that basically casts this object array to an occupation type array. Then we can do a for loop, and we'll do var O type for occupation type in this thing. And then for each occupation type, we need to add to the database. We can do database.add. So this is, a lot like a list, except now we need to add a key value pair. And it should even kind of tell us what it thinks our key value pair is. So it's telling us that it's an occupation type, right here. So here we do O type, and then the value is a list of occupation data. So here we need to create a new list occupation data. Okay, so now the next step is to iterate through all of the jobs in our file, and then put them or add them to the right list of occupation data. So the database is basically several different lists for each of the occupation types, and we can use the occupation type to look that up. So this brings us to the package that we just imported. To use it up here, we need to do using btl.io, and that basically imports that namespace. And that basically lets us use the Dict Reader class. So then here we can do var Dict Reader class equals new Dict Reader, and then you just give this the resource string, which is this thing. And this has something that basically lets you iterate through each of the rows, and it looks at the header and creates a dictionary of the column header name and the column value for each of the rows. So then we can do for each var d and Dict Reader. So we're looping through the rows of the file. So if we do like d occupation type, we get the occupation type as a string. Or if we do d.occupation, we get the occupation as a string. Or we can do median income and get the median income as a string. So basically, we can create a occupation data struct. So this thing, we can create one of these. So we'll call this var o_data equals new occupation data. And then basically we just need to go through and assign these. So o_data.occupation type will equal, so we can actually use system.enum.parse to take this string and then parse it into the occupation type. And since our column names match exactly these names, we can, this is why this works. So if you look at the column names, they have these underscores exactly. We also need to cast this as occupation type here. Oh, and then here we need to specify occupation type. Oh, and then we also have to do type of here. Yeah, the system.enum is a little bit messy with the syntax, but I mean, basically, when you get to the point where you're like, oh, I gotta iterate over an enum, then you just like think of, okay, where did I do that? Like, okay, I think I had to do that in the workplace class, and then you can just find where you did it and copy this line of code, and then you're off to the races. This is not something that I would even try to, well, I mean, it's not that I don't try to remember it. If you do it 20 times, then yeah, you'll probably remember it, but I probably wouldn't even, if you're doing this 20 times, then you're probably doing something else wrong. You should come up with a simpler way of doing it, so you could just, yeah, well, I'm kind of rambling now, but I think you get the point. And then here we don't have to do anything because occupation is already a string, so that should be fine. Here, median income is a string, so we actually need to turn it into a float. We can do system.convert to single. So a float is also a single as opposed to a double. A float or a single uses 4 bytes. That's 32 bits, so 32 1 or zeros to represent a number. And then a double uses twice that many, uses 8 bytes or 64 bits to represent a number. Okay, so that actually fills out the occupation data struct, and then we need to add it to our database. So then we would do database at occupation type. So now this is pointing to the list, and then here we can do .add. And then we add this occupation data that we just created. Alright, so that reads through all the data. And then we don't need to return anything because this database is defined in as a property of the workplace. So any other methods in the class would be able to access it. Okay, so let's go ahead and test this. What I want to do is launch this when we start. So I'll just do load occupation data, and then I'll put a breakpoint here and attach it to Unity. Alright, so here we can see our database is null because we haven't initialized it yet. So after we initialize it, it's empty, and now we can start adding key value pairs to our database. If I look at the database now, we can see the keys, those occupation type enums. And then on this side we can see the lists, and right now they're all empty lists. So then it'll set up the Dict Reader and start iterating through each of the rows. I'm going to go ahead and break right here. So we can see OData is not defined at this point. And if we look at D is a dictionary, and again here are the key value pairs. So they're all string pairs, and we can see that there's occupation type, occupation count, median income, percent grad, percent population, log, the column names from our file, and then here are the values for the first row. So basically we'll go through, that will set the occupation type as management occupations. Now we will set occupation as a string, so this is for chief executives. We'll convert the median income to a float and then set it there, so that ends up being 87514. Same deal with required job skill, percent grad, percent population, and then here we're adding the occupation type to the database. So now if Visual Studio comes back, so now if we look at the database objects, should let us open this up. Now we see that the value count is 1. We have one occupation data struct on here. So this is the one that we just added. So that seems to be doing the trick. You know, it'll go through and do another 504 there. I'm going to go ahead and stop this. And we can move on to our next task. I'm also going to unpause, or unplay, I guess, stop Unity.